Hi YouTube, this is John from Graybeard 3D. Today we're going to be discussing speed printing, and this is something I started doing because for EARTH this year they decided to have a speed contest for the Benchy, and this is the Benchy I did. It was a 15-minute Benchy. I was looking at just different techniques of trying to squeeze more speed out of the printer, and using some of these techniques, I think the best compromise there is we're able to find out what will and what won't affect quality, and perhaps just start printing faster altogether. So with that, let's go ahead and get started. Let me switch to this little intro here. So as I said, this is for the speed Benchy. Earlier today I did 4 or 5 other streams. Go ahead and check those out too, and go ahead and hit the like and subscribe if you like what you're seeing here. This stream is going to be relatively quick, and it's all going to be through a shared desktop, so not too much camera work here. So let's go ahead and switch to our desktop, and we're going to switch to Slick 3R, and I'm going to try to keep my eye on comments too. So let me slide my Slick 3R over. There we go, and let me just make sure. I don't think we've switched over yet. I just want to see where YouTube is, see if everything's coming through okay. Yep. Okay. So everybody should be able to see, and I called it Slick 3R, and it's not anymore. It's Prusa Slicer. This is version 2.1.0. It really shouldn't matter which version of Prusa Slicer you have. The reason I like Prusa Slicer for this particular type of exercise is because the print times are very accurate for a Prusa printer. And by very accurate, I mean usually within 15-20 seconds. So we're able to use this information as we're slicing it without actually trying the print to see if we've improved the speed or if we've made things worse. So this is really going to help us. Even if you don't have a Prusa, you can still practice techniques in here using the Prusa print times, even if it's going to be a little bit different on your printer, because it's still going to be relative. So if you're able to speed it up a minute or two here, then on your printer it's going to speed up, whatever the difference might be. Instead of a minute, it might be 45 seconds, or it might be it might speed it up a minute 15. It just depends. So here we have in Prusa Slicer standard Benchy. We're on the standard Prusa 0.20 speed setting, and we're on generic PLA, which is fine, and then we're on the Prusa Mark 3S. So if we go with the default settings here, we're going to slice this up. And I should say I should look up who made the Benchy. I know it, I just can't recall it right now, but I'll look up who made the Benchy, and I'll give appropriate credit where that's due in the description below. But anyway, we did this slice. This is with the speed 2.0 set or 0.20 setting on the Prusa Slicer, and you see our Benchy is coming out at 1 hour and 34 minutes. So that's not very fast. How are we going to get something that would normally print in 1 hour 34 minutes down to 15 minutes? That is an extreme change in speed, and so there's a few things we want to look at here. Obviously, the first thing we can do is say, okay, well, if we print a thicker layer, then all of a sudden our speed will improve. So a thicker layer means we're going to have to print fewer layers. So we'll go up to a 3.0 layer there, and we'll hit slice again. All right, we're down to 59 minutes here. We've already cut out a half hour just by changing that layer thickness. Now, understanding that a 0.4 nozzle can do a little bit more than 0.30, it can actually do about 0.32, and you might even be able to squeeze it some more. But we saw how much just increasing that layer height changed so much. So with that, let's just try to increase that layer height just a little bit more. So manually inside of print settings, we're going to come in and type a 0.32. So that should help out a lot. The other thing we'll notice is how many perimeters we're printing around this. So the more perimeters and the more lines we have to lay down, that's going to affect how fast we print. If we print less, we go faster. So we're going to make perimeters 1. And the other thing we have are top and bottom layers, but we're not going to go into that right now. Let's see where we're at right now with our speed. And for speed, I'm looking down here. So interesting enough, I lowered I increased the layer thickness, and the time went up. So I'm doing less parameters, and I'm doing thicker layers, and my time went up. That's very interesting. We'll see where that goes. Like if I go back to 0.30, does time go back down? Nope, time goes up again. So doing a single parameter versus two parameters, it actually says the time went up. We'll have to determine why that is, and maybe there's some techniques we can use to figure that out. But for now, we'll stay at the 0.32 because printing thicker we know is going to go ahead and let it go faster. Parameters, we'll leave at 1 for now. Solid layers, top and bottom. This is where we can save a lot. Let's go ahead and just say we're going to do one bottom and one top. And one top and one bottom is very aggressive. You'll be lucky if you get this thing to hold together, but we'll go ahead and try it. All right, so we're down to 50 minutes here. We're making some progress. From here, some changes you'll see won't actually do too much. Like we changed the parameters and it actually went slower. Let's change that back to 2 and see what happens. Does it go faster? 51 minutes. So 2 parameters is coming out as faster than 1 parameter. And so we start to say, okay, why is this? Why does 2 parameters make it print faster? Would 3 parameters make this print faster? So let's say 3. Come on back. And we're at 52 minutes. So 3 isn't working for us. So that's okay. But I have a feeling I know why this oops, let's go to 2 again. I have a feeling I know why this 2 parameters is making it faster. So we're at 51 minutes with 2 parameters. I think that meant an Amazon delivery came. But we're going to change our infill. We're going to change it to 0. So 0 infill. And we're going to slice again. Now we're down to 43 minutes. We're making some real progress here. But we're 0 infill, 1 top, 1 bottom layer. We're at 2 parameters. But now I bet you if we go back down to 1 parameter, we'll beat that 43 minutes. Now we're at 31 minutes. So now when we cut that parameter, it went down drastically. So what was happening is when we went down from 2 parameters to 1 parameter, it was having to do extra infill, which means infill draws at weird shapes and stuff, and so you end up with weird speed coming off of that because it has to move a lot and jump around for infill. So by getting rid of the infill, we're able to cut our time all the way down to 31 minutes. So we've already shaved 1 hour off of this Benchy. This is going pretty well for us so far. I have found that these times are usually within about 15 seconds of reality. So using these times, it's actually a great gauge, especially if you have a Prusa printer, because you know, hey, this is how fast it's going to come through. We're pretty scraped here. Now there's another trick we can do, and this trick might not be so obvious with everybody. We have a few things going on here. The Prusa has a fan that blows like this direction, this up and down direction. So it blows across. This bow of the Benchy is a curved surface that is that's kind of tricky for the Benchy or for printing, and you end up with some drooping sometimes there because the cooling isn't good enough. The other thing that we have going on here is we're dealing with print speeds, and we're dealing with the maximum speeds of axes. And when we're dealing with that, the bed can only move so fast, and the left and right can only move so fast. If we put certain walls at an angle, at a 45-degree angle, that means the bed or the X and the Y can move simultaneously to draw it, which is going to increase the speed. So we can get 2 benefits out of rotating this Benchy. Let me make sure I'm on it. So we're going to hit rotate here, and we're going to rotate it exactly 45 degrees here. So we rotate this Benchy, and what this does is it allows the cooling fan to get more of this backside here, so it's going to help it. But what it also does is it allows like all these straight edges here along this Benchy, it allows them to draw faster because acceleration has changed for each axis. So if we slice now, we should beat 31 minutes. We didn't too much, but it helps. If we had infill, you would have seen a much more drastic change, which is, here, let me show you real quick, because it is a significant change, and I imagine that most of us, are going to print with infill, and so knowing this trick of rotating your model can help a lot. So I have 10% infill, and I'm rotated, and I'm at 45 minutes. And let me rotate back, and let's see what our time goes to. 48 minutes. So we're shaving some time with this rotation trick. And again, not only is the rotation helping shave time, but it's also helping the cooling of that front bow, which is usually a tricky part of the Benchy. So let's go ahead and drop our infill back to 0 for now. And we'll come back to infill anyway. We need to fix up some problem areas that we know is going to go wrong here. Now, when we're looking at this, we can also cycle through and see, okay, what's this look like on the inside? And we can start to see that this thing is mostly hollow. It's all empty, and it's all just shell right now. So that can be, that can be good, that can be bad, but whatever it is, there it is. So let's look at some other things we can do to improve speed, and then we'll come back and address the shell situation here. So let's come back to some speed issues. We've done infill, we're at 0, that's fine. Skirt and brim, well, we actually don't need a skirt. The skirt kind of counts toward our print time, so we're going to set our loops to 0 because we just don't need a skirt, and that's going to shave a little bit. We were at 31, now we should be at 30. Okay, so we shaved a minute there, but every little bit helps. Support material, we're not using it, so it's not affecting us. Now we're at speed. In speed, it's like easy to say, okay, we're just going to crank everything and everything will be great. So, maybe we say, okay, 200 for that. The Prusa can handle 200 pretty well. 200 for infill. Maybe 200 for solid infill. Top solid infill, 200. What the heck? Support material, we're not using any, so it shouldn't matter. Bridging. Bridging, maybe we want to keep it conservative at 80. Travel, we'll go to 200. Oops, I lost my buffer. And first layer speed, well, so the first layer is going to hurt us a lot. So maybe we squeeze out a little bit more speed out of first layer. So maybe we say 60 on that. So we still have these small parameters and external parameters, but we'll come back to that because I think everything here is practically an external parameter now, so we might not see much improvement. No, we're at 30 minutes. So let's go back to our print settings and let's affect these two. So small parameters, maybe we do that at 150, and external parameters, maybe we do that at 100. And come back to our platter and slice again and see, did we get any speed out of it? No. Why aren't we getting speed out of this? So there's a few views here that help us a lot. Down here, if you click this view and you can start looking through, there's one called speed, and we can click on speed and we can look. Most of this Benchy is printing at 15 millimeters a second. Even though we've cranked the speed to 200, we are not printing at 200. And we might say why, but we do see one line in here that's printing at 76 millimeters per second. And that's just like that green line over here in the area that says green is 76. And what's the difference between that layer and all these other layers? And what it comes down to is this layer is printing a lot of stuff. It's doing a lot of stuff. Same with this bottom layer. This is telling us that the reason we're going slow is time-based. There is a feature in the slicer based on filament settings that says slow down if the layer is less than X number of seconds. And this thing really starts to hurt us. So right here we have slow down if the layer is less than this number of seconds. We can change this to anything we want. We can change it to 5 seconds. We can disable it altogether if we want it to. And we also have minimum print speed. Minimum print speed, we can just say, okay, well, if it's going to slow down, I don't want it slowing down any less than 60. Might not be a great idea. So if you overdo this, that smokestack on top of the Benchy, which I managed to get this one to print perfect, or near perfect, if you go too aggressive, that smokestack will turn into what looks like a pile of poo on top of your Benchy. So you don't want that. So let's go back to our print settings. Now we did change that drastically. Let's see what kind of times we get now. Ooh, 18 minutes. We're getting there. Look at that. So 18 minutes looks great. Let's look at some of these other things. We have these other parameters here. These are acceleration controls. Let's go ahead and crank these up. We're just going to set them all to like 2,000. First layer, I'm going to leave at 1,000. And default, I'm going to make to 2,000. So let's see what this does right now. We'll go back to the platter. So acceleration is how quickly, you know, if we say go 200 millimeters a second, how quickly from stop does it get to 200? So the faster you get to 200, the more issues you're going to have later on. But just cranking that helped us a lot. So we cranked all those speeds. We can maybe look at tweaking the first layer a bit. Maybe we can even tweak the speed of the first layer. But we have all of these speeds already set. They're very aggressive. Let's look at what else we have in here. What's under advanced? So over here we don't really have anything. Bridge flow rate, nothing great. Resolution is nothing great. So nothing there really, and nothing output options. Filament settings, we've already played with these times a little bit. We can try to play with them some more, and to see what it's doing right now, let's go ahead and switch the view back to speed. And for speed, we can see, okay, we're still not getting the speed we need, and it's probably because of the cooling settings. And if we set to volumetric flow rate, we can see we're getting near that 15 mark, and we probably don't want to exceed 15. So we want to watch out. Even 12 is pretty aggressive. As you start to exceed that volumetric flow rate, which is just how fast material is flowing through your nozzle, the greater the chance of the extruder skipping, because the extruder's, you know, pushing so hard, and it's getting too fast for the nozzle. A way to help this, and this is another little trick, is you want to crank up some temperature on this. So let's go to filament settings and crank up some temperature. For the extruder, maybe we'll say 235 for the first layer, and maybe 235 for the other layers. The first layer, though, I think we are going slower, so maybe 225. So cranking it like this is going to make the filament more molten, and it's going to let the extruder push it easier as we approach that 15 millimeter or 15 whatever it is, cubic something. But as we approach that, this hotness, this melt is going to help it flow a lot easier right through that nozzle. There's only so much you can do, though. Eventually you're just cooking the filament on the outside, and then the inside staying hard because it can't keep up. So that's where you have to switch to something like a volcano or a super volcano, because it has a longer melt zone and it's able to do the higher temperatures on the same materials. Let's look what else we have under here. Filament type, PLA, filament overrides, nothing there, nothing there, nothing there. Okay, so we're at our platter. We're at 1743. Now there's another trick in here. Something we're doing in here that we don't necessarily need to do is under extruder 1, we have a lift Z. So for lift Z, right now we're lifting. We don't want to lift at all. So that means every time it has to move, it has to lift up, move over, and set back down. And that lift and that set back down takes time. So we're not going to lift anymore. That means we might end up with a little bit of stringing. We still have retraction helping us, but we still might end up with a little bit of stringing off of this. But still, let's go ahead and try that. Let's see what we're at now. We're at 1646. We're getting there. As you see, the closer we get to that 15-minute mark, everything else becomes trickier. This is really pushing things to an extreme here. So our lift Z, we're at 0 there. Our minimum travel, etc. But somewhere in here, we should have a retraction speed. And retraction speed's 35. Let's go ahead and crank that to 60. See if that helps at all. I think for most purposes, see, we're hitting a bit of a wall. We're not really changing much here. Let's look at one other thing under machine limits here. So we cranked a lot of our acceleration to 2,000, but our machine maximum accelerations in here are set to 1,000. So we're just going to change these two. So Control C, 2,000, 2,000, Z, we can leave Z alone. Extruder, 5,000 is fine. Blah, blah, blah. Maximum acceleration when extruding, we're going to say that's 2,000. Maximum acceleration when retracting, we're going to say is 2,000. We have some other numbers here. These are our jerk numbers, and this is like another order. So if you have, I don't even want to try to explain it, but basically, you know, the acceleration is how quickly you get to your 200, and then the jerk is like how quickly you get to that acceleration of that 200, and then, you know, you can go into some other orders of it too, but we don't really deal with that in our slicers. But let's go ahead and make our jerk a little bit higher. A lot of printers print at like 12, 10, that sort of stuff out of the gate. Prusa has this set down pretty conservatively, probably for better looking prints. The default value out of Slick 3R is 10, but Prusa sets it to 8. So they're kind of playing around a little bit with it to get the best appearance. All right, so we've changed all of those. Let's go ahead and look. What are we at now? We're at 1444. Now you'll notice that our stealth mode numbers, which used to be pretty much in line with our normal mode numbers, have remained in the 16-minute mark. And that's because when we came in here and changed all these 2000s, we left the stealth mode on the right alone. It doesn't matter. It means like you're actually able to make one file, and by changing to stealth mode or to normal mode, you could have one file that maybe goes slower but looks better, and one file that goes fast, just by changing that mode. So right now that looks great. I don't think I had anything else really in here. We have our retraction speed. Maybe we can crank that higher, make that 100. Yep. So the retraction looks like was what was holding us up a lot. So now we're 1436. We're getting within that 15-minute mark. So we're beating the 15 minutes, but there's no way this is printing, not the way it's currently designed. So the big problem with this right now is nothing else other than this area right here, this flat area. That thing is going to fail horribly. That whole area there, that's just going to fail. Same with this whole area here, this little piece, the bottom of like whatever that storage container is on the boat. That's going to fail horribly. So what we want to do is try to get some support to help these out. And we can do a few different things to do that. We don't want to just add support everywhere. We want to just have the support to help those sort of features out. So we know that this first one hits at, what is that, 660? 6.6. So, and I'm looking at the right over here at the number where I first saw it show up. So 660 right there. So I know I need some support right around there. At about the 660 mark. So in Prusa Slicer, we can add a modifier, and one is a support, or no, we don't want the support enforcer, sorry, but we just want to add a generic modifier, and here we're going to add a, maybe we'll do a box. Yeah, I don't want to get too crazy with it. So here we have a box, and we're going to rotate the box just to be at the same 45 as the boat. And then we can scale it, and we're just using the built-in features of Prusa Slicer. And what else do we want to do with this? Let me make sure I haven't accidentally, like, yeah, I thought so. So the scaling kind of like pulled it away from the bed as well. Of course, none of these features want to work. So we want to get this on the bed. And we want this box to be, what, the 660 and the Z. So we can make that 6.6. The X and Y don't really matter so much, but I find that maybe we want, we're locked in our scale factor, sorry about that. So we're at 660, but maybe we want this to be like 20 and 20, something like that. And we'll go ahead and drag it in there. And hopefully this will work. I did this similar method. I did it a little bit more carefully, and it worked out fine. But hopefully this will work for us. And what we're going to do, I actually don't like the 20 on, maybe we'll do a 15. And maybe we'll do a 10. Okay. I wish there was an easy way to kind of see in there what it's doing, but we're going to do a move and let's see, kind of pull it in there a little bit and maybe pull it back a little bit and right there. So we can still kind of see it, but we're covering this area here. So with this generic box, what we want to do is we want to go ahead and change our settings for this. And we should be able to. So settings, infill. So I right clicked on it. It was the right click that did it. And now we can set a fill density. And maybe we want a 5% fill. And if we tab, then we can choose what type of fill. And we'll leave it at grid for now. We'll see if anything matters. So if we do a slice, and we look, all we're getting with 5% fill is that one line. That's all it's helping us do. That's not going to be enough. We know that's not going to be enough. So there's a few things we can do with this. One thing we can do with this is under our print settings, we're printing at like a 45 degree and our infill has like a fill angle of 45 degrees. Maybe we just make that a 0 degree infill angle and see what happens with it. Okay, so it changed. It's now over here, but 5% clearly is not enough. So let's try 10%. Slice again. All right, now we're getting some sort of infill that looks like it might help us. And yep, it looks like when we draw this, it looks almost perfect. If only we had a little bit up there, but you know what? This is probably enough to survive. Yeah, that looks like enough to survive. Our print time right now is 15 minutes. So as we continue this exercise, and I'm probably not going to continue much more, but it's a similar method of trying to make sure we get infill everywhere else. Something else I noticed is there's a technique. Let me see. If we say our infill everywhere, let me set it to 5%. Slice now. If we say infill everywhere, you see how this draws all the way to the wall? It seems to work perfect. Which would, if we got this thing to draw all the way to the wall, we wouldn't need to worry about infilling as much. But our speed went to crap. We're now at 19 minutes. We lost everything. But just by having any infill, it actually changed the way it draws this whole top pattern, which might be a bug in Slicer. But let's try maybe a 1% infill and see if we can keep that going all the way to the wall. So it does keep it. Our time is still crap at 1%, but it does keep it going to the wall. It's just funny when we go to 0% infill and we do a slice, got to click off to get it to slice, we lose it. It doesn't draw to the wall anymore. It's very weird. It no longer tries. And I got to submit this as a bug report of some sort, because the only thing that changed was the infill, and it doesn't make sense why it is now drawing it. It's not drawing it all the way through anymore. So maybe, I wonder if it'll let me do a fractional infill. So I did a 0.1. Does it let me do a fractional? It does. My time is still crap. It looks like that fractional, I'm still at some sort of minimum. I'm still at the 18 mark. So I think we just get rounded up to the nearest whole number. I wish there was a way we could say, okay, let's draw this particular layer different. And maybe we can. Maybe we can say at this height, we're going to add 1% infill, but not actually have infill here. I wonder if it will process that. So this is, what is that? 852 or 820. We'll try either. Now I'm going to warn you. You know, we've done a lot of work here. I've pretty much shown you a lot of the tricks that I'm working with here. But my warning is, this is also where, hey Sean, how are you doing? This is also where Prusa Slicer likes to crash. So what we're gonna do is under this Benchy STL, and I wonder if I need to click this one. What we want to do is add a height range modifier. And so we can specify layers. So we'll start at, what was that number? 852, 8.52, and stop at height 902. I guess is that the next number? No. 884, 8.84. So we hit the plus here, and yeah, that's where Prusa Slicer crashes. I've tried a whole bunch of different ways, and I get it to crash all the time like that. I don't think it's going to recover any of the work we did, which is fine. I don't really care. Hey, David, thank you for joining. Good morning. So, yeah, ignore. But what I can do is I have, I believe I have my original Benchy project, the one I have at 15 minutes. I think I saved it. And I want to search in downloads. And Benchy, name matches Benchy. See, it's not seeing it. It should be there. Yeah, let me do it a different way here. Okay, so we'll quit that and we'll use this. Because, look, the Benchy is already working. And I want to say 15. It's probably this one that says Benchy 15. All right, so here's what I had for the Benchy 15, and when we slice it, and this is probably a different version. No, okay, so I have 1423 out of this, and I think you might have seen some of those modifiers I had in there, but there's been some additional techniques I've learned throughout the time as well. So one thing I'm doing with this is I am printing. Well, it looks like I'm using gyroid. That was a bad idea. So I learned that lesson, but it looks like I am using a little bit of infill in here, and that little bit of infill looks like it's enough to, oh, actually, maybe it's the two bottom layers. Let me see what I'm doing here. Perimeters 2, tops are 3, and bottom is 1. So I think I focused the emphasis on the top, because that's the bottom you'll never see, well, hardly see. So you can actually read those words too. But these numbers are really what you want to play with. I actually left parameters at 2, and I'm wondering if I did that to compensate for the other issue. But let me set parameters to 1. Let me see if it gets a little faster. Let's see. Do we beat 1430? 1228. Did we lose anything? So I guess I have a 1228 Benchy. Possibility, I guess. I'll call it a possibility. But you'll see I have two generic boxes. Let me switch back over to this. I have a box for this and I have a box for that, really to add the infill. And it looks like just having this box that intersects that platform actually lets that platform draw outward. And I guess the three tops help as well. So 1228 Benchy, this could potentially print as. The only thing I would do is probably switch this infill from gyroid over to rectilinear, and maybe this infill from gyroid to rectilinear, and let's see what happens. Did I ruin my speed? No, I'm still at 1230. Did I improve the support structure? A little bit. I actually would like, so that's the support structure. I actually would like this one, if this was rotated 45 degrees, it would look great. It would support this box much better. So I wonder if I can do that. Nope, infill, sorry guys. Infill, we want this to be at 0, and let's see what happens. That helps a lot. I lost some time though, but I have 13 minutes, 48 seconds. This is going to support that platform much better, and this looks like it's going to support that front much better. Although I want to say the front doesn't look too bad, but this is the Benchy that we have. Same sort of techniques. Let's look at some of these settings just to be sure. So I have 0 Z lift. I have good retraction speed. Oh, that's something else I did. I cut my retraction length down to 0.6. I think the normal is higher than that. I'd have to go look real quick. Let me see. Let me switch over to the Mark 3S. Okay, so the normal is 0.8. So I'm retracting less, and I might even be able to cut this down to a 0.4. So let me switch back to the Benchy one and cut that down to a 0.4, and that might speed it up some more. Let's look at platter. What were we at? 13 something? 1332. So I think we saved 17 seconds. So again, this whole exercise is about. Hey, John Mack. Man, you're a regular viewer. This whole exercise is about just shaving this time off to get a Benchy that still looks like a Benchy. It's not the best Benchy in the world. It does have its rough sides, but knowing some of these tricks, knowing about these 45-degree angles, knowing that Prusa slicer is going to behave differently with 0 infill, etc., knowing that sort of stuff really changes the way we can work with this, because now we can say, okay, well, let's look at what settings, if now we're at 15 minutes, let's start to dial some of it back and start to get that quality back. So we could approach this from a quality problem and say, okay, well, we're having some pretty rough surface here. And why do we have this rough surface here? The rough surface looks like all over, but it looks like it might be on different layers. And I'm curious what happens if we say, show me the retractions. Where is retractions? Feature types. Oh, it's a checkbox. So show me retractions. So right now, most retractions are happening inside. We do have some outside. And yeah, so that corner there, home all day, already in bed. Wow, I wish I could be in bed. All right, let me transition real quick. Oops, I do apologize for playing that because that was not supposed to be that transition. So let me try it. Focus, focus, focus. That edge right there, that's where retractions are happening. So it tells me that maybe we can tweak that retraction. Oh, I don't want more parameters. It's going to slow it down. But maybe we can tweak that retraction because maybe we need to extrude less on the restart, or maybe we need to, who knows, whatever it might be, but we can start tweaking that to fix that. We can start looking at other areas to fix. Now, some stuff is really good. I think that hole is pretty round, maybe a little sagging, and it could be because I did crank the heat so much. The front there, pretty straight on there. The bow is not curled under. It's actually shaped pretty well, and the smokestack held up very well. And the smokestack is an area. I wish this thing would focus on the Benchy, not me, guys. The smokestack is another area that a lot of people fail on, and this is actually an easy thing to handle. So that's just looking at some of the things we did. You can still read the label on the bottom. If I can get it to focus right, but the label is clearly there. You can't really read the back, but that's okay. Yeah, more parameters. Obviously, we can go back to what we had and get a great looking Benchy. But the goal is to get a fast Benchy, and we can start to see, absolutely where some things fall apart. The top here, this looks really bad. You can see holes all the way through. I don't think I can show you, but you can see holes all the way down into it, because that top layer is so thin. Although I am doing 3 top layers, it's just that thin. The top of the roof is pretty bad. But we can start dialing some things back and bring them back to normal levels and seeing if we can get to some sort of compromise. And I've been working on that a little bit. So that's our fast Benchy. We're at 1332, which beat my last time by far. And those white dots, those are retraction moves, which leads to other interesting things. You see these white dots right here around this porthole? Well, on some of my earlier benches, somewhere in the 30-minute mark, I thought it was ringing from belts or something because I'm moving so fast. But no, it's these retractions here, and it actually looked like it was just ghosting. It looked like the ringing from, or the ghosting from belts. But it actually, when I went back and looked at this model and I looked at these things, it's like this is actually, these retractions here, it made it all look like there was a little bit of ghosting. It was tricking me. So sometimes if you see ghosting, it might not be ghosting. It might be retraction settings, just kind of like coincidentally near some sort of feature. So we have that Benchy. We have a speed of 1332, which is very good. We've improved the infill. I might save this back because we've improved the infill. Save project as, and we'll call this Benchy 13. Let's look at anything else I might have done in here. It should be very similar to what we looked at before, but we'll look at speed. Okay, so I just cranked to 300 instead of 200. So I went everything at 300, just right out the bat. Solid color filament instead of translucent. Yeah, John, this is the Knights War red. It's just what I had laying around at that moment in time at Earth. I absolutely, like, if I was doing this for a showpiece, I absolutely would use like a gray or something. Oh, I just realized I'm trying to show you my desktop, and you guys are looking at this other thing. So let me switch that, and I need to make sure I'm on that for later. Okay, so now you guys can see my desktop. Hey, Paul, welcome to the stream. I really like that you guys come back. So as you can see here, I set all the speeds to 300. So that's probably where this got a little bit faster. And I got all the accelerations to 3000. And max print speed, I changed that as well to 300. Under advanced, what did I change? I guess something with support material, but we're not doing anything with support material, so it shouldn't have mattered. And then print settings. Retraction length is 0.4. Lift to 0. That's a big time saver. Machine limits, crank those all to 3000 except for the Z. I left that at 1000, although I could probably do something with that. So everything's cranked. My jerk is at 10. I might be able to squeeze it to 12 or 15. The Prusa seems to handle these 300 speeds very well. I don't think speed is the issue with this Benchy. If I had parameters back, I wonder how it would look. And filament settings, I did set this to 225 for other layers. However, if you watch the video, I actually up the temperature even more when I'm printing, and I do it manually. And then at the end, right before the smokestack, because I didn't want the smokestack to overheat, I manually turned the temperature down. So that was just to compensate for, I didn't want to reslice the file because I didn't have a laptop at the time. I just wanted it to print, and I knew that these things were coming up. So how's your night, Paul? So more temperature when you're printing this fast because you need to worry about that volumetric feed rate. Okay, so this is another big savings. Slow down if layer print time is below 1 second, and my minimum print speed is 60. That's a huge time savings. Did I change anything here? Max volumetric speed. So that's probably too aggressive. Who knows? That might be too aggressive, but I did it. So let's see. So we have that, and if we go look at our speed right now, we can see that for most of this Benchy, we're printing at about 173. For some of it, we're getting in the 2s, and it's weird that, you know, the walls are printing so slow. And then some of it we slow down a lot, and this might be the 1 second thing for these little pillars, because it's just hit it, hit it, hit it, and hit it. That might be under a second. But maybe this one, I'm like, okay, well, why is that one so, you know, so slow as well? It could also be because it's a fast layer. Oh, that's good, Paul. I need to, can I do it from the screen? I need to make John a moderator. All right. So there we have it. We have a very fast Benchy, and you can see up here at the smokestack how much it slowed down. And that's actually what we want. We want it to slow down, or else this thing will turn into what looks like a pile of poo. So you'll end up with, I know I'm a small window right now. Let me see. You'll end up with plastic crap. So, all right. So that's pretty much it. Let me jump over to my other profile. Let me say, okay, let's clean this up a little bit. File, new project. All right, let me find my Benchy. I'm going to find the STL. And we're going to say, okay, we're not going to use these other things. Let's go back to all the normal stuff. Discard changes and continue. Yes. Go back to generic PLA. Go back to 2.0 speed. Say yes. So when we slice, we should be at that 1 hour 30 minutes. Yep. And what we want to do is look at, so I'm working on the speed profile. And the speed profile is supposed to be taking some of the concepts from that fast, kind of like that fast moving. Your T800, yeah, that's the one I saw last night, right? So let's see kind of what kind of speed. Oh, 136. Maybe this is not the one I was working on. Maybe it's the super one. I forget. All right, 128. So it's not much faster. At least not for this model. I think there was another model where that goes a lot faster. Let's look at some. Oh, see. Yeah, I cranked it only a little bit in some areas. So I'm going to continue to work on it though. But what I'm hoping to do is take some of the techniques here, take some of the things that really help and some of the things that don't help, and just tune in on the ones that really help and try to get something that might print in an hour that's going to look spectacular, or maybe something that'll print in 30 minutes. But if I start to get a profile that will print a normal file twice as fast, then I can start, you know, yeah, infill 7. But if I get a profile that starts to print normally twice as fast as I could before, then all of a sudden I'm increasing the output of my printer by 2 times, which is going to be great. And that's what I really hope to get out of trying this speed exercise, because first I get down to the basics, then I want to build it back up and try to get something that's going to print fast, or twice as fast, but still retain as much quality as possible. I don't mind losing some. If you missed it earlier today, I built a Prusa slicer profile for the Ender 3, and with that Prusa slicer profile, let me switch my screen for you guys. OBS and transition. With that Prusa slicer profile, this is the Yoda that came out. This is by Chris Fries. I'm probably mispronouncing his name in every stream. So he came out really good, and that's off that profile. And the bottom layer looks really good too, which means that bed leveling by eyesight is fine. And let me see what else I have to show. I think that might be it. Oh, I wanted to, before I kind of got off of this, what I want to do is just make sure. Okay, so unless this is a lie, I don't think it's a lie. I'm trying to see who it is though. I forget the guy's name who made the Benchy. However, the Benchy I downloaded came from Thingiverse, and it says it's by Creative Tools. So I just want to reference that. Boom, boom, boom. I was hoping his name would be in here. So anyway, Creative Tools, Jolly Benchy Torture Test off of Thingiverse. Thing item number 763622. The Yoda is off of my Mini Factory, and you can just look for the baby Yoda and you'll see it. I think it's called something, the first child or something. Something like that. So that's it. Thank you so much for tuning in today. I don't think I have any more videos for the day. I did 5 or 6 today, so that's going to be it, guys. I really appreciate everybody who came out, especially John Mack, who I think made an appearance in every video. Hold on, where'd my window go real quick? I want to make sure I'm not missing any chat. Paul, who made every video too. I think he made every video. And I think I've seen David a few times today, and Sean Butler made it a few times today. Also, Sean made it by a few other times, etc. Okay, so it's Daniel, and he does work for Creative Tools. Thank you very much, John Mack. Daniel Norrie, right? Norrie? So I knew who it was, I just couldn't remember. Anyway, I do thank Daniel, obviously, for making the Benchy, and Chris for making the awesome Baby Yoda. And I do thank all of you for watching. I hope you have a great Christmas. I do plan to do more live streams before Christmas. The only challenge I have with live streams is it takes me about 2 hours to set up to start, which is why if I get it all set up, I want to do 5 in a day. But yeah, this is absolutely fun. I really love doing this stuff. If you have anything you want to see with Tinkercad, Fusion, 3D printing, Prusa, whatever, it doesn't matter. If I can do it, I'll try to help you out. Just let me know in the comments below. Please subscribe if you haven't. Hit the bell to be notified next time I do a live stream, because I do them kind of randomly. And follow me on Twitter, graybeard_3D. So thank you all much, and I'll see you next time. Yeah, Daniel Norrie. Okay. Thank you, John. Yeah, I see. I knew it. It was just a matter of time. Thanks, Paul. Thank you so much for coming out. I really appreciate it, guys. Y'all have a good night.